This is CPM Calculus Chapter 5, Number 20. Investigate horizontal asymptotes for quotients of linear functions by examining the results of this limit for different values of a, b, c, and d. So let's go ahead and jump in because we want to go ahead and summarize our findings in Part A. So let's go ahead and take the limit. And instead of plugging in different values, let's go ahead and leave them as a, b, c, and d. Okay, when we take the limit as x approaches infinity, what is this going to give us? All right, well, remember that what can we do? We can multiply in 1, right? This is equal to the limit as x approaches infinity of ax plus b over cx plus d times 1, right? This is the same thing. If I could represent 1 as 1 over x times divided by 1 over x, because this right here is 1 as well, right? So if I do that, let's go ahead and distribute this in, because this is multiplying it in to each term, right? So 1 over x times ax is going to be ax over x. 1 over x times b is going to be b over x over 1 over x times cx is cx over x. 1 over x times d is d over x. Alright? And then we can simplify this. Ax over x is just a, plus b over x, over cx over x is just c, plus d over x. And there are a lot of ways of going ahead and simplifying this. But this is one of the best ways, I think, to understand it intuitively or just to understand it. Okay? Because now we can go ahead and take the limit. If we apply the limit, as x goes to infinity, b over infinity becomes 0, right? This is going to become 0. D over infinity is going to become 0 as well, right? Because it's going to be some constant d or some constant b divided by infinity becomes 0. So when you apply the limit, you're just left with a in the numerator and c in the denominator. Okay? And this right here is the horizontal, let's say y equals to a over c is the horizontal asymptote. If our original function was y is equal to ax plus b over cx plus d. This is our function. I'll even, instead of calling it y, I'm going to call it f of x. So if f of x is equal to this, then we have a horizontal asymptote, which is equal to y equals to a over c. Okay? Let's go into part B, because this is explaining it. This is our findings. We know that we have an asymptote of y equals to a over c. No matter what a is and no matter what c is, this is our asymptote. For part B, we want to find a function f of x as a horizontal asymptote of y equals 3. Okay? So let's go ahead and write part B. We want a horizontal asymptote of y is equal to 3, and also we want a vertical asymptote x is equal to negative 5. Asymptote, just abbreviate it, x is equal to negative 5. Right? So all we do is want to find a function f of x. Alright, so horizontal asymptote to be 3, we know that there has to be some terms, right? If we have something, f of x is equal to ax plus b over cx plus d, we know that a over c has to equal to 3. To have a vertical asymptote, we know that the denominator has to equal to 0. So we could say cx plus d has to equal to 0, right? So solving for x, we subtract d from both sides. We get cx equals to negative d. Divide by c, we get x is equal to negative d over c. And this has to equal to negative 5. So as long as our function has the attributes of a over c is equal to 3 and negative d over c is equal to negative 5, then we're good. So let's see if we can find a few different examples. So one example is going to be A over C is equal to 3. Let's make A 3 and C 1. Okay? B isn't used here at all, so B doesn't matter. It could be 25. It could be 2. It could be 5. It could be 36. Right? B doesn't matter. I'm going to leave it as a variable because it doesn't matter what it is at this point. C over D. Okay, D over C though needs to be negative D over C has to be negative 5. So what that's going to tell us is that D over C here has to be positive 5. So, right? If negative D over C has to be negative 5, we can multiply both sides by negative 1, and D over C has to be positive 5. So if we have C is 1, right? C in the denominator is 1, that means D has to be 5. So this right here is one example, right? Can you find another example? F of x is equal to, well, we know A over C has to be 3. So if this is 9x, this would be 3x, right? B doesn't matter. This could be anything. But we know D over C has to be 5. Well, C here is 3. To get D over C equal to 5 when C is 3, we multiply 3 by both sides, we get D has to be 15. Right? So in this case, we would want this to be the value for D. Okay, so there's an infinite number of solutions. You can come up with yours, but just know that if your function has this look right here, we need A over C has to equal to 3, and D over C has to equal to 5. These are the requirements. Alright, so that's going to end for us CPM Calculus Chapter 5, number 20.